Hello, grade 12. So today, besibheka lana i-photoelectric effect. So sisebenzisa PhET simulation ukuze sihlaziye indaba ye-photoelectric effect. So i-photoelectric effect is very simple topic. So la kwi-photoelectric effect, we have two plate. But the most important plate esizobe sifocus kulona ileli elingaka left. Leli eline-coating. Leya coating siyibiza ngani? Siyibiza ke-metal plate. For instance, for now, it is still sodium. Mengiyishintsha uyayibona iyashintsha nokhala wayo. Seyu-zinc, kayishintsha yaba brownish, seyu-copper, kayishintsha yaba platinum, kayishintsha yaba black, seyu-calcium. So that is our metal plate. Then la phezulu sizoba na intensity. We are having an intensity. The intensity is speaking about the amount of light which is being shown or which is being shined upon a particular metal surface. So the amount of light, in which intensity is indirectly linked to the amount of photons emitted by that particular light. Meaning if I increase the intensity of light, I'm increasing the amount of photons emitted by the light. Then here we are having our range of frequencies, basically that will be our spectrum. This is a visible spectrum from red to violet. Then at this point we are having ultraviolet, and at the other end of red we are having infrared. But here between infrared and ultraviolet we are having visible light. So note the fact that even if I change the frequencies of light without having intensity being switched on, there won't be any electrons which will be ejected. Why? Because according to photoelectric effect, which says it is a phenomenon whereby light of suitable frequency is shown upon a metal surface and electrons are ejected. For now, there is no light which is being shown upon this metal surface. So let us try to go with a smaller intensity and see what happens. So let's go around 40. Yes, there it is. So we are having an intensity of around 40, and then we have a frequency there. For our frequency, we'll look at it from the perspective of a wavelength. Remember the fact that wavelength and frequency, they are inversely proportional to each other. So if the wavelength is increasing, it means that the frequency is decreasing. So let's just try to increase the wavelength and let's see what will happen. I'm going for a yellow color. Let's just observe. It seems like there are no electrons or photoelectrons which are getting ejected. Now remember one thing. What did I do? I changed the frequency of light. So at this point, you might be asked about the investigative question. What might be the investigative question for this scenario? So what was my independent variable? What did I change? It is the frequency of light. What was my dependent variable? It is the emission of photoelectrons. What was my control? It was my intensity and my work function. So how can you go about asking the investigative question? What effect does a decrease in frequency have upon the emission of electron, provided that the work function and the light intensity are kept constant? That could be a beautiful investigative question for you to actually lay down, because it shows all the aspects of an investigative question: the independent variable, the dependent variable, and the control variable. So let us try to increase the intensity and see what would happen. Increasing the intensity to around 73 now. Still nothing is happening. It goes straight to 100, but still nothing is happening. And then you ask yourself, what might cause this? Okay, asibuyele move. Let us remember that the cause of electrons to be ejected from a metal surface, it has nothing to do with intensity, but it has to do with a frequency of suitable nature, meaning it must be suitable, it must be sufficient to actually eject these electrons from a metal surface. It means even if I increase the frequency, still the energy is not affected, meaning the intensity does not affect the energy of electrons. So let us try to increase the frequency and see what would happen. Let's go for green. Now we are starting to see some electrons being ejected. Even here, we could still ask an investigative question. Senze njani? Sishintshile ini ifrequency. Mesishintsha ifrequency, sifuna ukubona ukuphuma kwama-electron from a metal surface. I-intensity asiyishintshanga, still is 100%. Ne-metal surface asiyishintshanga, still kusawu-sodium. So ngabuza investigative question. What effect does an increase in frequency of light have upon the emission of electron, provided that the light intensity and the work function are kept constant? Let us change the intensity. Let's go for 50%. So now we have changed the intensity to 50%. So let us see what happens. There's a bit of electrons which are getting emitted per unit time. So meaning what? Meaning decreasing intensity also decreases the amount of photoelectron ejected per unit time. So we can also ask an investigative question also here. What effect does a decrease in light intensity have upon the emission of electron, provided that the frequency of light and the work function are kept constant? So that is another investigative question that you could ask. Mfunda ungaphandle yakanga ufele this topic, a beautiful one indeed. So we can also change the work function. Who said we cannot change the work function? Let's change the work function. Let's go for zinc and see what would happen. Remember that the green light was a suitable frequency when we had sodium. But now for zinc, what is happening? Is there nothing happening? Ooh. So what does that imply? It implies the fact that the frequency of green is not suitable to eject electron from the zinc metal. So the frequency of light is less than the threshold frequency of what? Of the zinc metal. So no photoelectric effect is taking place. Let's try to increase the frequency. Let's go for blue and see what would happen. Still no effect. What does that mean? It means that the frequency of light is less than the threshold frequency of a metal. So therefore, there is no photoelectric effect taking place. Let's go for even higher frequency we can find, which is ultraviolet. Ultraviolet, ooh, wow, they are shooting electrons. Meaning what? Meaning ultraviolet has a suitable frequency to eject electron from a metal surface. That is why we are having photoelectric effect. So let us try, let me just bring it here, 179 nanometers. Let me try and change the metal also to copper and see what would happen. Still electrons are getting ejected. I've changed what? The metal from zinc to copper. So I'm asking an investigative question. What effect does a change in work function of a metal have upon the emission of electron, provided that light intensity and the frequency of light are kept constant? That is also an investigative question to beautifully ask. So all these things are very necessary for you to be able to interpret, analyze, and understand the process of photoelectric effect. I hope this was a fruitful lesson. Thank you, great top learner. Hope that you understood quite clearly. Besama laphana lapha sishaya ngesizulu, sithinte ngesizulu, sibuye sibuyisele kwisilungu. Let's hope that you understood quite clearly. Catch you next in the next lesson. Thank you and God bless.